Hi and welcome to another video. I'm going to explain logarithms, and it's a final revision, so I'm going to try to explain everything about logarithms. So what is a logarithm? Simply, if I have two numbers and I know that 1 to the power of another one gives me number c, so a to the power of b is c, I could leave the a alone by writing this. And now if you think about it, a is alone on one side of the equation. The way to leave the b alone is to write it like this. And this means what number to the power of a gives me c, and that number would be b. If I was to do this with actual numbers, I could have that 2 to the power of 3 is equal to 8, equal, I could say that 2 is a cubic root of 8, and similarly I could write that log base 2 of 8 is equal to 3. So this is what logarithms are and where they come from. That's the explanation. Now there are some consequences with logarithms, and that's what we're going to look at next. Quite simply, these are the consequences, they are the logarithm rules, and you can find them in your formula booklet. If you look at the very first one is just what I just explained right now. The next one has a simple consequence. If I have logarithm base 2 of, for example, 50, I could write this as logarithm base 2 of, for example, 2 times 25. And according to this, I could write it, well, this is something as logarithm base 2 of 2 plus logarithm base 2 of 25. But now, of course, I know and I realize that logarithm base 2 of 2, doesn't that mean 2 to the power of something gives me 2? That's going to be 1. So that would be 1 plus log 225. It's just another way to write these things, and I can do this because I use this rule here. And when I have 2 times 25 here, I can write that log base 2 of 2 and log base 2 of 25. Similarly, the other rules work in a very similar manner, and I'm going to stop for a minute to explain this one. If you look at your calculator, you will realize that you have two keys. You have log and you have ln. These two keys are both logarithms. This one, in general, is the log base 10. And this one is the log base the number e, which is a very important number. So, for example, if you put in your calculator, if you have the number, you put log 1000, you're going to get 3, because 10 to the power of 3 gives me 1000. Whereas if you put ln 1000, you're going to get something very different, because it's going to be whatever 2.17, the number e, to the power of something. This has to give you 1000. It's going to be a very different number. So the change of base, the last one I want to say, I do it because it might be hard to calculate, for example, log base 2 of 25. And I simply solve this by using the change of base. Look at this carefully, and I can do log 25 base 10 of 25 divided by log of 2, and that will give me the decimal answer of this part here. So that's basically all you need to know about logarithms. There are, of course, also some rules of exponents, which you should know by now, but nevertheless I'm going to do a few exercises. Solve the following equation. Now, this was extracted from past papers, so it's very important that you know how to do this sort of exercise. Now, log base 9 of 81, log base 9 of 1 over 9, and log base 9 of 3 equals to log base 9 of x. There are many ways in which I can do this, but what I'm going to do is realize, well, if the logarithms are adding here, I have two logarithms adding, I can put it all inside one logarithm multiplying. So I could have log base 9 of 81 times 1 over 9 plus log base 9 of 3 equals log base 9 of x. Now this I can multiply, and I'm going to end up with a 9. Log base 9 of 9 plus log base 9 of 3 equals log base 9 of x. And similarly I can do the same thing here, and I would end up with log base 9 of 9 times 3, 27, equals log base 9 of x. And well, if log base 9 of a number is is equal to log base 9 of another number, it must be that those numbers are equal. So indeed, I just end up saying, well, 27 is equal to x. And that would be the way to solve this exercise. I could have also done it by realizing, well, log base 9 of 81, that must be 2, because 9 to the power of 2 is 81. This must be minus 1. And this one here must be log base 9 to the power of 3. This is going to be 1/2. And once I do this this exercise, I would realize that I would get 1 plus 1/2. I would get 3/2 equal to log base 9 of x, which means that 9 to the power of 3/2 is equal to x, which is going to give me 27. It's just another way to do it. And finally, let's do one more exercise that requires, taken from a past paper, that requires a slightly different use. So this is a very typical one, and I want you all guys to be very able to do this sort of exercise. Suppose that I have log base c, they don't tell me what, of 3 is equal to p, and log base c of 5 is equal to q. And they ask me to find an expression in terms of p and q. So the way to do it is, I'm going to do part 1. I can realize this is the same thing as log base c of 3 times 5. And now I can write this as log base c of 3 plus log base c of 5, which I can use my p and q here and realize, well, this is simply p plus q. In the second example, I can write this, well, it's quite a bit harder, but I can say, well, isn't this log base c of 25, isn't that a log base c of 5 squared? And isn't that the same thing as 2 times log base c of 5, which is simply 2 times q? And these two would be the answers to the simple exercise, because there are expressions in terms of p and q for these two values. Well, thank you very much for watching, and I'll catch up with you next time. Bye.